Okay, welcome to the next topic. Actually, here in this topic, we are going to discuss about the various crystallographic direction and directions and planes. Okay, and the physical significance of this crystallographic directions and plane are a lot because these are widely used to represent the plane and how it look like, and in order to express these things in a mathematical way, we need these directions and plane. And because of these directions and planes, actually we used to express the crystal structure and the various patterns and all in this fashion. So let us discuss the thing, and in this particular video actually we will discuss only the crystallographic directions. Planes will be discussed in the next video. Okay, and the important thing needed to specify the position of an atom is the crystallographic plane of atom or the crystallographic directions. So using these crystallographic planes or the crystallographic directions, we use to specify the position of an atom or a group of atoms. Okay. So let us see what do you mean by the crystallographic plane. Okay, like crystallographic direction, and here. Okay, so here the crystallographic directions is defined as like a line between 2 points, or it can be also called as a vector. Okay, so like suppose if there is one point here, and like say this point, and we are having this point, so there's 2 points. These 2 points are interconnected by a line. This direction, this direction is known as a crystallographic direction. So it can be represented using certain fashions, and here we will see how these things are represented. So here actually we will see these things, and let us see this Miller indices. So this is the Miller indices, and Miller indices is a system. Okay, like a system of notations which is designating the crystallographic planes and direction. So that is the Miller indices, and here we can see this is the Miller indices for this thing is the Miller indices for the for our directions, and this all things represents the direction. First we will see the direction, and then we will see the plane. So regarding the direction, I want to tell one more thing. Directions are these coordinates of selected points in the unit cells. Like we will have some coordinates, it's represented by x, y, and z. So these are the three directions which we will see, and these directions are designated using some reference numbers. Okay, so these numbers actually, in fact these numbers represents the distance from this origin. Okay, this is the origin. So we will see the directions or the distance from the origins, and this distance from the origins are designated with the help of these Miller indices. Okay, let us see these things. Now let us see the crystallographic directions, and we are much focused into this direction part now. And here we can see that based on the intersection with the cell boundaries, and it is indicated with square brackets. Okay, these are the these things, directions. We cannot simply write it in this fashion. It is having a standard representation. So this standard representation is denoted by using three values, like it is known as h, k, and l. These are the Miller indices for the directions. Okay, so before starting, like let us see these 6 direction and how it is taken and all. Let us see. Now let us see the first direction. first direction here, you can see that the first direction is the point here where it is represented by 1 0 and 0. Okay, let's see how it is made. So as discussed earlier, this is the point. This point is known as the origin, where the coordinate value is 0 0 0. Okay, that point, origin point, is represented in this fashion, and we have x direction in this way, and here is the y, and here we have the z direction. Okay, now what is 1 0 0? So it is very simple. You can see that 1 represent, that means it is that point is away from one unit from x-axis, in x-axis, and in y-axis and z-axis it does not have any change. So like we can see that it lies in this way. So here comes the point 1 in x. Okay, so here, and for 0 for y and 0 for z lies here. So here we can say that the point lies 1 0 0 lies here. Okay. So this is the that particular point 1 0 0. 1 0 0. So this is that one. Okay. Now let us see, or let us move to the other point. So this here, this is the direction 2. As you can see, this is the direction 2, and here actually you can see that the direction is 0 1 and 0. That means in x-axis it is 0, and for 1 for the y-axis, and 0 again for the z-axis. So let's see this part once again. So here we can see that for x-axis the value is 0, so it lies here only. For y-axis the value is 1, so it again moves to 1, so here it's 1. And for z-axis we don't have any value, so again it lies here only. So in general, so the value, the point lies here, that is 0 1 0. Okay, so this is that direction from origin to this point. Okay. So this direction is represented by 0 1 and 0. Now let us see if the value is like, if we are going to tell some kind of value. I will write it here like 0 0 1. So where, which portion it will be? Like for x it will be 0, y it will be 0, so in z it will be 0. This is not marked here, and it's an additional, so it will be like this. So 0 0 1. And now let us move to the next direction, that is direction number 3. Okay, in direction number 3 we can see that the value is 1 0 1. So here you can see that the value 1 is for the x-axis, it comes here 1, and for y-axis there is no change. So in this axis there is no change, so it will be 0. And for z-axis, okay, for z-axis the value is 1, that means comes here. So the 1 will be here and another one will be here. One will be here and another point will be here. So what here I am doing is that here we need to move these points. So that intersection point, okay, this will be the intersection. This point we will have that value, that is 1 0 and 1. Okay, that intersection point we need to consider. Now let's move to the direction number 4. Here what we will see is that 1 1 1. That means for x-axis there is 1, and for y-axis there is 1, and for z-axis there is 1. So the all together it should meet at common point. So what we can do is that we need to extend these things. Okay, so here one is there, another one is there, and another one is there. So altogether all these one can meet at one point. So that is let us see how it is. So here, before that, I think I can erase all those things for clear understanding. Okay. So what is happening here is that here we will see 1 1 1. That means x-axis there is 1 point. So it is this point is x. So and here z also, actually we have 1 point. So z 1, and for y-axis also, and the common meeting point of all those things. Okay, let us see common meeting point. Okay, here we have, and here we all these points meet together at a single point. Okay, and that point, in fact, that point is known as, okay, that point is actually this 1 1 1. Okay, so that particular direction, this direction, okay, this direction, the fourth direction is taken as 1 1. Okay, I think everyone understood this concept. And now let us move to the other direction, that is the fifth direction. Okay, let's see how it is drawn. The fifth direction. Fifth direction, actually the difference is that on x-axis it will be half, and y-axis it will be 1, and z-axis it will be 0. So in x-axis I will take half the distance. Okay, only half the distance, and in y-axis it will be full unit. Okay, up to here, and z-axis actually no unit or no direction is there. So in fact, actually what we need to do is that we need to consider half. So in x-axis actually there is a half is there. So this will be the half I will take, and y-axis actually this full unit is there. So what we will do is that we will just extend it, and this point is termed as half, 1 and 0. And for easy represent, we cannot write like this half, 1 and 0. For that we will multiply throughout with the denominator, that is 2. So the value will become 1, 2 and 0. That fashion we will write it here, 1, 2 and 0. Okay, and similarly for the direction 6, actually again it is half and 1. So for A we will take half, and for B actually we will take half. In direction Y we will take half, and Z it will be 1. So again we can see that there is a common point here. There is a half, and it will meet at this point. Let us say more clearly, this half, and in the y-axis it will lie in this plane. So it will go and it will join, and this point is termed as 6. Okay, which is represented by 1, sorry, it's termed as 1, 1, 2. Okay, now let us see the next thing. As I said before, there should not be any fractions. We will convert all the things to integers. So as said before, if you take half distance from x-axis and half distance from y-axis and 1 unit distance in z-axis. We will represent it by 1, 1, 2. That means we need to multiply this thing with 2. Here the denominator, common denominator is 2, so I should multiply it. Okay. Similarly, take another case. Here we have the coordinate system, and here we have the point coordinates, that is in x-axis it is 3 by 4, in y-axis it is again 3 by 4, and z-axis it's 1. So the common denominator is just 4. So what we need to do is that we need to multiply it with 4 throughout. Okay, but in effect actually we will take x-axis like 3 by 4 here. We will take a point like this, and we will take 3 by 4 here. In y-axis also we will take somewhat 3 by 4, and for z-axis the value is just 20. So all these things together, what we will do is that we will just extend, and all together it will meet at this common point, which is denoted by this 3, 3, 4. And one important thing which you need to know is that the negative direction. Okay, the negative direction, how to represent the negative direction. We will see the negative direction representation in the next slide, but for the time being just keep it in mind that anywhere if a negative value is coming, for example if you are taking some negative 1 in y-axis like this, if you are taking some negative value in 1, it will be -1 here. So if this point we need to note it down, we will note it by the help of a top bar. Okay, this one, this top bar is used to represent a negative direction or a negative axis. Another more crystallographic direction is represent 0, 1, 1. Okay, 0 for x-axis, 1 for y-axis, and 1 for the z-axis, and the intersection point is taken as 0, 0, 0, 1, 1. Similarly, here also for x-axis we have this value here for half, and for y-axis the value is unity, and for the z-axis again this will be half. So altogether, how we will see. Okay, so the common point, okay, common representation lies here. So here it will come 1, 2, and now here actually you need to find the crystallographic directions for this this particular direction. Here I think let us see this one. Here we can see that for x-axis it is just half, x-axis it is just half, for y-axis it is just half, and for z I think it is 1. So the direction in general we will write it as half, half, and 1. So multiplying throughout by 2 we will get the directions in this form. Sorry. So directions in general we will write it like 1, 1, and 2. I think it's clear for all. So you want to draw the direction of this particular thing. Now let's see how to draw. Okay, here we have a negative direction, that is 2 is here, 2 bar is there. So 1 is along the positive x-axis, this minus 2, like 2 bar we will take it as -2. It will be along negative y-axis, and 1 again in the positive z-axis. So let us take this as a unit, this axis coordinate system, x, y, and z is there, and here you can see we want to take these things, the value dimensions of y in, or the directions of the y in the negative. So again, one unit we will move to this part. So this will be 1. We will take this as a -1. So here we will take this value as a -1, and we can see that, but the value here up here is just -2. So what we will do is that we will add one more block here. So here the value will be -1, and here the value will be -2. Okay. So in x-axis the value is -2, and for the y it is just 1 here, and z the value is 1 here, and for y actually the value comes here, that's -2. So altogether we can see that all the three directions will commonly join at one point. Okay, and this point is this 1, 2 bar and 1. Okay, this is the way in which the directions are taken. Now there's another question, like determine the indices for the direction shown in the accompanying figure. Okay. For this part, actually, for x direction, x, the axis is projection is like on a/2, lies on a/2, and for the b we have full length here, and z actually there is no. So the value will be half on the x, 1 will be there on the y-axis, and 0 will be there for the z-axis. So the reduction techniques, like means multiplying it by the denominator, because no fractions are allowed. So we will represent it by 1, 2, 0. So in general the value will be determined by, or the enclosure will be like 1, 2, 0. Okay. And this process in which we remove the fractions is known as reduction. Okay, another thing, I recommend all to pause the video for the moment and try to draw this direction 1 bar 0 direction within a cubic cell. Okay. So this is how it looks like. Here is our cube. So this is the positive, we will call it as a positive cube, but here one direction, that is the y direction, is negative. So what we will do is that we will move to the other side. So x, we have one positive direction, so as discussed here. For the x, actually 1 is there, so this is the positive 1, and for the y it is just what to say, this is -1, and for z the value is 0, so it lies here. So the common point where it lies is this one. So this is the 1 bar 0 direction. The next video we will see the crystallographic plane, and for the time being I recommend everyone to find some crystallographic directions and try to plot this direction to ensure your knowledge. And thank you for the attention. The next class we will see the crystallographic planes.